1977 Sony KV1512 Trinitron color. This set is in like mint condition. Super low hour. Except I just noticed that the Sony logo fell off. And I don't know if it fell off here or in the car. I'm not sure where it fell off. Anyway, as you can see here, the issue is no vertical deflection. So today we're going to attempt to diagnose that. Like I said, this set is absolutely beautiful. "15" Let's take a look at the back. The original Sony antenna. All the original screws. No vertical deflection is a common failure of old TVs. It's where you just get a line in the middle of the screen and nothing else. And the problem with that is, of course, it can damage the CRT. So what I'm going to do before I power this up, I'm going to turn the picture all the way down, and I'm going to turn the brightness all the way down, and we're not going to sit on this very long. So exactly, that's what we got, and we're not going to sit on that because we will damage this beautiful low hour Trinitron CRT. Trying to kill that reflection there. Econo quick. I wonder if that means instant on. Now all I've been asked to do on this set is just to fix it. Not to recap it, not to resolder everything, just to fix it. Using the airplane as background music, we're going to do a little thorough inspection here. So this is the IF. This is kind of neat. It looks like when you take those screws out, you also disconnect the chassis from the wood surround here, so you can just pull the whole thing out and service it. I guess because it's so low hour that the solders all look very good here. Nothing is baked, not a lot of thermal cycles. All right. Brightness is down, picture is down. First thing I'm going to do is, there's our line. I'm going to kind of nudge the vertical hold size. Nothing. 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 Just want to tweak those controls to make sure it isn't a control issue before we dig in. Looks like we have a screen control here, and the pot is straight this way. So what I'm going to do is I'm going to turn it on. I'm going to see if I can turn the screen down to where I barely see that line. Yeah, I've got the screen turned down to where I just barely see that line. I don't want to damage the tube. So that way I can work on it without, you know, measuring voltages and stuff for an extended period of time without worrying about damaging the CRT. So here we go, Sony color 1977, so February 77, so this is borderline 76. Let's get into it. So I think maybe the best way to go about this, since it's solid state, is to and these are not really my specialty. Tube stuff and early solid state stuff is kind of my interest in what I grew up working on, but we'll diagnose it, no problem. So let's go after it. Maybe we'll take a look at the schematic. So here's our yoke right here, and our vertical is this, so it comes back into, it almost looks like a push-pull we got bamboo bants in the background. Somebody need a bamboo bants. Vertical driver, vertical oscillator, sync separator. So this is basically the circuit we're interested in right here. Vertical oscillator, vertical driver. This almost looks like a push-pull audio, but got a lot of electrolytics in here. Oh, when it died, apparently it was being watched and it just died, which could be an electrolytic, but is not likely. Usually when electrolytics go bad, generally they fade. They can just short, or they could just open, but usually the ESR goes up and the capacitance goes down. So we got a lot of electrolytics in here. We got a lot of diodes. We got a lot of transistors. I think maybe the best way to go about this is just to start measuring DC voltages. Okay, 571 is that one right there. 572 is that one right there. It looks like it's got a heat sink on it. So let's see. Well, is that 572 right there that does not have a heat sink on it? And let's see, 571 is right here next to this yoke connector right there. So the yoke connector, these Sonys always have this really fancy setup. I guess it's that one right there. See right here below that electrolytic. So why does this one look like it shows a heat sink on the paperwork here? Am I looking at the right thing? Yes, I sure am, because it says Q572 here. Okay. Let me see if I can actually find a photograph picture of that board in here, like this. Stand by. Sure enough, look at that. It shows a heat sink on that transistor. That's suspicious. So yeah, this transistor right here, does the board look discolored under that, like it's been getting hot? Not really. Look, it even shows the heat sink on the board. See that? It shows the heatsink on the board. Where'd the heatsink go? Where'd the heatsink at? This is a little sneak peek into the next Sony Trinitron we have to repair. I think this is basically the same set, except it's a remote set. So what I'm going to do, this is a 1541. I'm going to pop the back off because I have a feeling the deflection board is basically the same. And we'll take a look and see if this has that heat sink. And this set is in beautiful condition on the inside, like another 0 hour set. And it does have the heat sink. See it there? See that big heat sink around the transistor? Wow. Wonder how it got missing. Okay. Got to keep in mind this is also a hot chassis set, so in saying that, I'm not that worried about it because I'm on a wood bench and I got gloves on and I'm insulated from the ground, but just a note, it's a hot chassis set. So let's go after 572. I love the serviceability here. So let's go after the I really need a camera, man. 200 millivolts on the emitter. 0.09 on the collector. And 18 on the base. It's 572. What does 572? Okay, according to this, we should have 14 on the emitter. So let's go up here to 571 where our voltage okay, 25 volts. How do we end up with 44 volts there? What am I missing? This is isolated by a capacitor. Is it getting that just through pulse rectification? Anyway, let's just see what we got here. On the collector of 571, we should have something. Collector of 571. We have 22 volts. That might be right. Because if we have 25 minus 0.6 minus another 0.6, see if we can backtrace this through those diodes. Let's see, 571. Okay, here are the two diodes. So 23.31 there. So yeah, collector, we have 22. So we're getting voltage on the collector. Let's see what we got on the emitter. Probably nothing. 300 millivolts on the connector. Okay, let's see what we got on the base. 21.4. So do we think this transistor might be open? Maybe this one overheated and shorted because the heat sink's missing off of it, and this one went open. Checking the driver. Emitter we have 0. Base we have 0.09, and collector we have 18.4. So we have 18.4, basically 0 and 0. So I wonder if the oscillator is running. This whole thing might act as a loop, and without the oscillator running, none of this might conduct. So let me see. Collector should be 0.9, 0.4. or no, negative 0.4, right? So that would indicate it's running. That is 551. 551. On the emitter we have 0.04. On the collector we have 600 millivolts, 0.6. That's the emitter. And on the collector we have 0.689 on the collector. 0.6. Okay, so the oscillator is not running. Now, this is where the solid state stuff gets confusing. Is the reason why the oscillator is not running is because something in the loop is bad, or is the reason why the loop isn't working is because the oscillator is not running? So this is where I gotta like scratch my head for a minute. Stand by. Okay, so what makes a circuit oscillate? This is where the proficiency starts to wane with me. And so this right here, this oscillator, this 10 microfarad is a tantalum teardrop, and those like to short. Let me see. It's not, I'm trying to show, it's not this one right here. It's not that one. It's, I can't get it in the camera. See that blue one back behind it? Right here. I wonder if that thing is shorted. Well, according to this, it is not shorted. With the set turned on, I'm measuring 600 millivolts across the capacitor, which is about what I should be measuring. This is the oscillator transistor. I don't like taking parts out and testing them, but sometimes it's the faster way. I'm going to just spot check a couple parts here, especially that one that I initially said that didn't have the heat sink on it. I think I'm going to pull that one out and test it. And maybe the companion. This is a Nippon Kimicon, so these are not the ones that leaks. Yeah, not the ones that leaks. Yeah, this one looks good. Dry, no corrosion. Check's pretty damn good too. Here's the tantalum. God, the ESR is even a little bit tad high for a tantalum, but you can see it's much more accurate. Okay, look at the way this one tests. This is the one that was supposed to have the heat sink on it. Huh. So we have major leakage between 1 and 2. So we have major leakage between emitter and collector. So I should have just gone with my gut feeling there. Why is the heat sink missing off of this? You know, it'd probably burn it up. So if we had 1 ohm, basically a short between emitter and collector, that would draw a lot of current through this one and blow this one apart. So, you know, take the heat sink off of it, it overheats, shorts, and then blows this up. I just hope it didn't backfeed and blow this one up. Maybe I'll take this one out next. So it's kind of like a direct DC coupled audio amp. Okay, this is a 2SC1670, which is the driver. That's this one right here, which is the same as this one that I haven't checked yet. So this one, the driver is good. I should also say that this type of tester is not, you should be testing these with a higher voltage tester like something that'll do 20 volts. Okay, this is the other 1670 that is the output. So this is the one that should have had the heat sink on it. It overheated, it shorted, and it blew this sucker out. So I need to do a little bit of research now on transistors because I don't want counterfeit. OEM is not going to be available. So maybe I just get a couple modern TO220 packages out of a audio amp and pop them in there. It's an NTE 293 and 294. I'm looking for just a set of matched pair transistors, and I was looking at this. This is a Sony amp, but this is class D. You can tell by all the filtering on the output. So those are FETs, and that's the power supply. So I found this. This is a Fender 2005 Fender something. So I wonder what these are. I just want something that's not counterfeit, that's probably about 80 to 100 volts collector to emitter and an amp. And it's not that critical. Well, it might be critical, but for testing it's not. Okay, 2SA1306 is 160 volt at 1.5 amp PNP. Okay, and this one is the complement to the 2SA, so that works. 160 volt at 1.5 amp. Okay, according to a quick Googleizing, it looks like these are 140 volt 500 milliamps. So if the ones here on the Fender, if these are good, they are double what those are. Okay, apparently this one is good. This is the NPN. Okay, the PNP is also good. So how about if I just put them right on the bottom of the board? There's plenty of clearance here. I don't see why they need to be on the top. They're fully shielded. Okay, well here they are. They're just tacked on there for now. Base collector emitter, they actually line right up. And I put the capacitors back in, and the oscillator transistor and the driver transistor. Now here we go. This is a moment of truth. With solid state stuff, it just goes up in smoke. Oh wow, look at that. Come to daddy. We have repair. So what I'm going to do is I'm going to let this run for a minute and just feel these and see if they're getting warm. And I could always put a heat sink. I mean, these are so much more robust of a transistor than these were. So, you know, I'm not really worried about these failing. And yes, this one is notably warmer than this one. And, you know, this is the one that should have had the heat sink on it that I suspected from the very beginning shorted and blew this one out. So what I'm going to do is I'm going to grab the thermal camera just to give a visual. Okay, so you can see that transistor is much hotter than this other one over here. Here's the first one. And here's the second one down here. This is the NPN. This is the PNP. Definitely a noticeable difference there in the temperature. Look at that. That makes that transistor one of the hottest things on this board. So definitely I think we want to put a heat sink on that if we can fit it. I have a little heat sink here, and yes, I did put some fresh thermal compound on it. Okay, so let's put this back where it was, straight across. Okay, right there. It's about right. Okay, transistors have been installed. You can see the NPN one right here, and the PNP one that gets warmer, you can see it right there. So that is my solution. Okay. So basically we doubled the capacity of the transistors, and we put a heat sink on the one that gets a little bit warmer that was missing the heat sink. Since I'm not going OEM, what I'm going to do is I'm going to put this in here, since I basically modified this a little bit, and just leave these stashed down in here. I don't see where it could hurt anything, but you know, just documentation for future generations. Let's see if this will get channel 6. Channel 6. Tuner's dirty. There it is. Yeah, I see an issue here. It's not deflecting all the way to the top, and I notice this only has a vertical size, and if I adjust the vertical size, I get way too much on the bottom and not enough on the top. So I don't know if this is the transistors or a capacitor or another modification, because this TV is used on a different vertical sweep. It's used on like basically the PAL sweep rate. So when something might have been modified for that. So I need to do some research before I do anything. Okay, well, this is what happens when you can't get OEM parts, or you don't have OEM parts. I don't know if this issue of lack of deflection at the top now is due to differences in the transistors I put in there, or a dry capacitor, or some other modification. So the next step I got to go through is I got to get the NTE transistors. I got to try and find a heat sink for the PNP one, and I got to see if that corrects the deflection issue. You know, I really wanted to use the bigger transistors, but sometimes these things just don't work out well in real life. So we'll take a look at this in color with a good signal. 'Cause I would think I should be able to get color. Maybe the color's not working on this either. Okay, yeah, the color is working. It's just... color's working good. Let's see. Yeah. There we go. This is a vertical issue. Back at the Trinitron with the vertical deflection issue, I went and picked up the spec'd NTE ECG replacements, 293 and 294. And these actually look like the Sony transistors. Just the color of the case and that. Not that that means anything. About $3 a piece. Now the missing heatsink, I was looking around and I found this. This is for TO1 style, but we might be able to make that fit. Or I found this in my stash. Now this right here probably has as much surface area or more than this. So I might go with this route. Also what I might do is I'm just going to change them both. I was thinking, well, maybe I'll just change that one first and then see how the deflection looks and then do this one, but I'm just going to change them both. And I'm thinking now I'm going to use this as the heat sink. Okay, what do we think? Do I have everybody's blessing for such a thing? Okay. We're going to have to see how it works, but there's the PNP one that was missing the heatsink, and then I got the correct one in here. Let's power it up. Let's find out if the ones I had in there were okay and it's a capacitor problem. Let's see, we'll turn that down. Oh boy. Well, that definitely looks different. Boy, this wind is really getting insane. Well, that does not look right either. It's got a line through the middle of it. Oh, it just collapsed. Out of nowhere, it just collapsed. Something's up here. Well, it blew that up already. It's no longer a transistor. Damn. Okay, I just tacked that one back in, so I got one of each now. One big one and one small one. Turn the brightness down. This thing is difficult. Oh, look at that trash. Got a line in the middle. I got... It's like this whole thing is folded over right here. Oh wait, that just went away. What? That's better, but still got fold over at the top here. God, did it blow it up already? Just like instantly blows it up. Yeah, there went another one. It just like instantly blows it up. But it doesn't blow this up. So, yeah, this is the tough thing about working on solid state stuff, it doesn't red plate. It just, you just watch your money go up in smoke. That's $5 right there, just popped. Okay, I put this one back on here. Let's make sure it still works. I've literally cleaned the electronics store out of it'll do this weird thing, and then after a while it'll stop. So I'm going to recap the vertical. I got all new electrolytics for it. There's only like 3. Okay, I changed the 33. It goes from oscillator to base of the driver. No difference. Still got this fold over. Okay, this is the other 33. Nope. Now there's a 330 I'm going to change. The 330 has been changed. They're all testing good. Nope. Still can't get the deflection at the top. Still fold over at the top here. I'm going to try changing the driver transistor next. Okay, I changed the driver transistor and now it's completely wigging out. Now it won't even lock. I'm going to let it run for a minute, because it seems like it has a problem after it sits and you turn it on. It has a weird problem that goes away. I'm just going to let it run for a second here and see what happens. It's very bizarre. Seemed like it straightened itself out. I'm going to leave it off for 10 minutes. Go get something to eat and come back and try it again. It seems like it's got a problem like cold. After it sits for a while, you turn it on, it freaks out. That's why I thought it might be a capacitor, but I've completely recapped it. So it appears like what's going on here, and I know you really can't see this in the camera because the camera's trying to correct for it, but it's rolling and it's really bad at the top. It's like doubled over, and then you just let it run for a while and it straightens out on its own. And so I'm gonna change my assumption that the heatsink was the problem. That what's happening is when it's wigging out like this, it's frying the PNP transistor. I mean, it needs the heatsink, but since it's frying it instantly, it's because it's wigging out like this. This needs to stop before I do anything. I mean, I need to find this, and I guess cold spray. Has anyone tried this? This is, I don't usually do Coke. I like Pepsi, but, you know, in an attempt to be less white and more diverse, I decided to buy a Coca-Cola product. This thing is still wigging out, and it took it about 5 minutes, but it popped in. Yeah, this doesn't taste very ethnic, but okay. Oh, look at that! Now it's clinky twinkling at the top. This has got to be. I'm gonna try changing that tantalum capacitor. Okay, I changed the tantalum with an electrolytic. Tantalum should be more stable, lower ESR. Nope, and there it goes. What the hell is wrong with this thing? Is it the oscillator transistor? I might as well just change it out to try it. Okay, I put the driver transistor that I replaced in place of the oscillator. Nope, same thing. I changed out the NPN again with, oh, well, that's weird. But it's still, so that was this one, which was this one here. And I don't know why, I don't know why. I'm perplexed with this thing. Is this all a case of aftermarket transistors? I think I might have just found the whole problem. Yeah, a bit of an idiot. I will always concede when I screw up. This capacitor right here, this electrolytic, is this one right here, and 1.5 microfarads. Well, this is a 2.2. This is a 2.2 that's in the set, and it looks like it's going to be hard to see it on the camera, but looks like it's leaked. And a lot of times the capacitance will drop when they're cold, and as they warm up, as you've seen me do with heating them with a soldering iron, the capacitance will increase. This capacitor was down, like down in here. Do we see, can we see leakage here? Let me see, let me try and zoom in. Not really, but I wonder if this had been replaced before, because this is a 2.2 and this is a different brand. No, this is Nippon Kimicon. I'm going to let this cool off and we'll test it. Actually, I don't need to let it cool off. The ESR is 150 ohms. Oops, the one electrolytic I missed. I recapped the whole thing, but I couldn't find a 1.5. So, yeah, pretty poor. So, yeah, okay. Let me find a 2.2. As in, my local electronics store didn't have a 1.5. And since all the other, anyway, no excuses, I screwed up there. I bet this is the whole problem. How about this thing? 2.2 microfarads, 0 ohms. If I can make it fit. It's all I got. I don't have any electrolytics. Have to go get it, and I'm not in the mood for that right now. Can we make this damn thing fit in here somehow? Okay, let's see what happens now. What a butchered up operation this has become. I got the driver transistor in the oscillator department. I got, ooh, look at that. Whoa. Well, like totally, dude. We got full deflection at the top. It looks linear, even with the Fender guitar amp transistors. Imagine that. How do I turn the... What am I turning here? Vertical centering. Let's go to window circle. Window circle. Well, that's a little bit stretched. Let's turn that down. So it was not the transistors causing the problem. My Fender guitar amp transistors were fine. It was the capacitor. There's still a little bit of wiggling here. Not much. Okay, let me try and put this catastrophe back together. Okay, let me go over what I came up with here. All of this over one little stupid, elusive, hidden electrolytic. I ended up putting that good quality capacitor in there. I got the TO220 package transistors out of what we originally had thrown in. I don't know why that bad electrolytic, this capacitor, this bad electrolytic that I changed out with that red cap, why that was causing the PNP transistor to blow up immediately. I don't know why. I don't really care. It's fixed. I got the original oscillator transistor in, the tantalum teardrop in, which I was questioning, and I got the original driver in. So really all we got that's new now are all the capacitors. Well, all of these I've changed, which of course only one of them was bad. But yeah, basically cleaned all the flux off. Basically this whole problem was due to that one stupid electrolytic. 2.2 at 160 being dried out. So we'll have to take a look at the news on this. Gamer's choice. So, yeah. Talk about the long road to repair. I guess I'm going to have to just start recapping these. Oh, by the way, that's a film cap that I put in there. That'll never go bad. That'll never dry out. That's channel 6, the Franken FM Guadalupe radio, right off the rabbit ears.
El demonio lo que quiere es acabar con la humanidad.
This guy right here looks like the face of health and fitness.
Dios lo tiene retenido, ya hubiera acabado con la humanidad. Pero entonces
Satanico.
De ese grupo, de ese círculo de amistades que lo hicieron llegar.
We're just running it here just to kind of do a break-in and see, make sure it doesn't, something else doesn't fail. Okay, we're in the inside now, and it's picking up 88.1 K-Jazz along with 87.7 Radio Guadalupe. Move the
J-I-M-N-Y. So you can expect to hear some Jimi Hendrix songs, this time done by the great Gary Moore. And Gary does some fine work. You'll hear that today. And for our Blues Spotlight feature,
yeah, low power means low power.
And I think maybe you will agree, it's got something special about it.
Y estamos hablando de las capacidades
In our Blues Spotlight,
que tienen estos ángeles caídos, pero que no hacen lo que le da la gana, sino lo que Dios le permite.
This is old school technology, looking at analog over the air, moving the rabbit ears around, trying to get them to
hasta el exterminio. No. Si no se cruzan cables, pelones.
Let me get the generator. I don't know where the horizontal lines have gone on this. I think the generator's losing it. The vertical lines, the up and down lines, I don't know where they went. Oh, there we go. Anyway, it's fixed. Blue only, green only, red only. Good, it's done.